Okay, so what I'm going to do today is I'm going to walk through a process of utilizing Grasshopper to undertake a cut and fill exercise to create a bench. And I'm using George Williams' fantastic book, which is available free, very generously from George, on the QUT Creative Commons site. And it's called Grading, a Workbook of Manual Land Grading Techniques by George Williams. So this is his exercise workbook 2 of 2 on page 57. So first of all, the thing that I've done here, this is an example you'll see of the basic drawing that he utilizes, and I've rescaled it in Rhino. And I've also then traced the contours, which are then in 3D. And so the contours have all been using the gumball, have been moved to their correct location and height according to the labels, as well as the platform. So I'll turn that layer off. So obviously to get Grasshopper going over here, I'll set it up and I'm going to walk through this process. Now I have prepared this so it's not improvised. So because there are a couple of moments that are a little bit, not tricky, but like finicky. And so I trust that this will work. And so obviously the first thing we do is that we create and we use we get a curve, a selection of curves. And obviously when they're black, that black indicates that it's a parameter that's coming from Rhino, collecting data from Rhino. And so if I right click on that curve parameter and I go set multiple curves, I then can select all those. Now you can see if I'm dragging a window to the left here, it's like AutoCAD, it's a crossing window because it's built from AutoCAD originally. And now we can see that that selection of curves has been included. The first step I'm going to do is I'm going to make a mesh. And to do that, I'm going to divide those curves. And you'll see that there's a certain number of points there. And to change that point, I can create a slider, which I can either get to by clicking up here from parameters and then get it by clicking up there. Or I can type and I can say, create a range by saying 0 less than, say, 20. And that's just the syntax of writing it, and you get a number slider, and I plug that in there, and I'm going to choose 10. And this is essentially giving me the resolution. Obviously, the length of line will determine how much that's really, how much detail we're getting in there. So these short ones at the top here are getting a lot more detail. I'm in the habit of grouping my parameters to give them labels, and I'm just going to do this and say existing contours. And that's just a way of me remembering how to, what I'm working with. So then I'm also then going to group all of that together. And now I've got a series of points. What I can do now is I can use a Delaunay mesh, and then I can plug those points into that mesh. You see it looks a bit funny. What I can do is I can also then flatten it, and I think it'll look better. Flattening just means that technically Grasshopper will treats all of those lines as instances with the same parameter. I think that's the right way of saying it. And so basically flattening it means now it just regards it as a whole lot of different points, and then it's creating a surface by interpolating points. And so this is similar in the way that, for example, you might in Rhino, you create a patch curve, a patch surface, utilizing extract points from a series of polygons. So that's now my surface. And so I'm going to get all that together. And I'm going to take one more extra step here, which I have to admit I researched, which is I'm going to try to turn that mesh into a BREP, or a boundary representation. And I'm going to do that by choosing face boundaries. And again, I can't claim to have worked this out. I looked this up. And so then I'm going to go boundary, surfaces. And then what I'm going to do after that is I'm going to join them all together. And now what I have is I have and I have a B rep there. And just for good measure, I'm going to put a B rep on the other side. I probably don't need to actually, because that is 1, so I don't need to. So since that's just a way of interpolating or creating that there, I'm going to group those together there. And that's now all together my, group that all together, and I'm just going to call that caps existing topo surface. That's one of my building blocks. So the next part I'm going to do is I'm going to work in a slightly different way now. So the essence of what the system I'm doing is that I'm going to create a series of volumes from the platform that then will we'll use to either cut or to fill from a grade. And so to do this, I'll obviously create another curve set, which will just be actually one curve, right click again, and I'll set one curve, and now I'm going to select that guy. And so that's my platform right there. And as we can see, if we zoom in, that platform is up a bit and down a bit. So we're going to ultimately make it fit, which was George's exercise. Just going to group that, call that platform curve. So then once I've got that, what I'm going to do is I'm basically going to start by creating the cut volume. And so if we can remember that, when we express a grade, I'm using a panel to start with for the 1 because I'm not using a slider because that's not going to change. We express a grade by saying it's 1 in something. And generally, if we said it's 1 to 80, which is probably the flattest grade you're ever going to get, in a way, when we put those together, we could say, for this example that George uses, the cut batter is a 1 in 3 cut batter. So if you can see and imagine what I'm talking about, that's 1 in 3. So the way I work is I create a generalized volume that's bigger than it needs to be, and then I trim using it. And so the next thing I'm going to do then is I'm going to create a multiplier of 10. And that's because I'm going to multiply both of these sides by 10. Sometimes I think that Grasshopper is just a glorified calculator. So if I then get multiplication, you'll see the first thing I can do is in fact, I'm going to put this in the middle. Seems a weird thing to do, but it'll make a bit more sense in a second. And I'm going to go and multiply those two. And of course, the answer I get as we've lifted over here is 30. And so what I'm going to do is I'm going to start by offsetting that curve, this curve, which is the platform curve. I'm going to offset it by 30. And so I think this will make a little bit more sense in a second. And then what I'm going to do is I'm going to then move it vertically. And of course, when we move something, Grasshopper is entirely based around vectors. And so when it says translation vector, it means that kind of direction. And then obviously the geometry I'm going to use, I'm going to move up, is that offset rectangle square. And then from that, I'm then going to use the multiply again. And I'm going to say, 1 times 10, which of course is just 10, but still. And then after that, I'm going to move it in the direction of Z. In other words, the axis straight up. So I plug those together, and that together, and you can see that that is now moved up to that level. I'm going to turn off the preview of the lower level. And so we can see now I've got the rectangle, the original of the rectangle, the square of the platform, and then this upper level. And so in the first instance, what that's all doing is that it's really just creating a volume that's at 1 in 3. Really, that's what it's doing. It's creating a volume that's at 1 in 3. It's a simple thing it's doing. The 10 is, as I say, just a multiplier. So we can almost, I'm going to move it out of the way so we don't get confused, because it's really about that 1 in 3 there. So I'm now going to then use a rule surf command, which is again an old AutoCAD command. I'm going to get rule surf, and then we're going to basically get the original curve, and then we're going to get the moved curve, and it will create a surface between them. And I'm going to cap it. And so that now gives us a volume, which is, I'm going to call it, I'm going to group that all together, and then I'm going to call that the cut volume. So once we've created the cut volume, what we do is we pursue a process where I'm actually while we're still here, I'm also just going to copy that and do the same for the fill volume. So if I Control C, Control V, I get the same thing again. And now what I can do is I can, just through the quick change of a parameter, ungroup that. I can then just literally use a negative now. Oops. I can then basically put in a negative here. And we have it go down, as you can see. So that's the now that's the fill volume. And the fill volume that William specifies is 4. And so I'll just group that again. And that's now the fill volume. So I've got both of those. And so what I'm going to start though is, we're going to turn off everything in there that I'm not using at the moment. I'll turn the preview off. Since we're not working with that one, we'll also turn that preview off, so that we've literally just got those two volumes that we're working with there, the topo surface and the cut volume. And so I'm going to start by doing a reasonably simple operation, which is that I'm going to get and create a solid difference. I should say also I'm going to do the same up here with these ones to just turn off the previews. And again, that's not affecting the function, because the function is about enabled, not enabled. So generally keep things enabled. And so this is just so that we know what we're working with. I can also, in Rhino, I can turn those contours off so we don't see them. And so now what I'm going to do is I'm going to do a series of operations here where I'm going to start by doing a solid difference. And with the solid difference, I'm going to plug in that B rep and that B rep. Now, if you want to see what something looks like, you can use this green thing up here, which is only draw preview. And you can see that that's actually quite nicely chopped out the cut portion. And so that's the cut portion done, which is actually super handy. And so that's the cut portion. And so that just group that and call that the cut, the cut surface, let's call that. So we remember what we've got here. Now, for reasons that are not quite clear to me why, it's actually more complex, and I'll turn that off again, more complex now with the other portion, with the fill portion. So I'm going to turn off that preview so we just got what we're working with. And I'm also going to turn off the preview of that so that we've just literally got the part that we're working with now. Now, it's worth saying that, that Grasshopper works as a linear process. So one thing builds on the next. So we're now going to be working with that cut surface, and we're going to be working with this fill volume. So I'm going to actually, what I'm going to do with this one is I'm going to take out that cap there, and I'm just going to keep this rule surf here. So I'm also going to, at the moment, this platform is just a curve, but I'm actually going to make it a surface. So I'm going to make that into a B rep. And B rep just literally is like a surface, is really just simply means it's a surface solid of some sort. And so I'm just going to name that, and I'm going to call that, platform surface. So now that I've got that, what I'm going to do is I'm going to do a union. And a solid union basically joins things into one object. And so I'm going to drag this one into there. And if I press and hold the shift key when I drag from here, that brings those two together. And so that's now a solid with a cap on it, essentially. But it's not solid underneath. And this is quite important because when I cut this thing, I don't want to have to hack out the bottom. So rather than me capping the whole thing, I'm just capping the top of it. I learned that through trial and error. And so this is now a union essentially of those two things there. And so now what I'm going to do is I'm actually going to split that surface with this volume. So I'm going to use the term split B-rep, and I'm going to get the B-rep. I'm basically going to go from here and to here, and I'm going to split it. Now, if I click on this here, you'll see, and this is quite an important aspect, one thing I'm going to actually flatten this, and you'll see that there's actually, if we do this and we take a panel down here, it's worth remembering that everything is always objects, that there's actually two objects in here. And so what I'm going to do, I'm always curious to see what happens when we split this, when we flatten things. That becomes 4. So let's keep it as, let's unflatten that. And what I'm trying to do is I'm trying to get one piece of it. And so we use a function called list item. And we're trying to get one of those two. Now, if we looked at that list again, there actually is a tree in there. So there's actually a number of things below, but essentially there's a couple of items, 1 and 2. So if I then go in here, you'll see that I've got this, if I go to flatten, you'll see there's actually a number of things, and I want to get one of them out the bottom. So I'm going to, if we look how many there are now, because I flattened it, there's 4. And so what I'm going to do is I'm going to use a slider, which goes from 0 to 3, because don't forget in Grasshopper, things always start with 0. It's a digital thing, right? So now that I've flattened that, you'll see there's actually 4 items, 1, 2, 3, 4. And so I want a particular one. I don't want that one, which is 0. What I want is actually, let me try something else here. What happens if I unflatten that? So what I really want is I actually want this bit at the front. So let me flatten it again. So, here I'm just trying to retrieve one piece basically. And what I really want is that piece, because that's the edge of the fill. Because don't forget, I have this B-rep here. And so now I have the platform top and the fill component. And so what I can also do now that I've found it, I can leave that there, but what you can also do is you can also choose to actually internalize that data. And now that remembers that value that we had in there, so we don't have excess sliders around the place. So we now have that component. And so what we can say is here is that what we really have is if we group that together, what we have is actually at this point is the fill, what did I call it before? The fill surface. And, when we've got that there like that, what we can do is we're now trying to basically, and we've got here is the union of those two, obviously. I'm going to turn off that one. I'm going to turn off that one or turn the preview off. We've got that. But if you see, it's now on top of that surface. The aim ultimately is to have one continuous volume. And so what I want to do now is I want to actually start to cut the volume. I want to cut out of this surface. And so the way that that's going to work is that essentially I'm going to extrude 2 items down and then trim it out of the surface. And so I'm going to start by extruding this. I'm going to extrude a number of things. I'm going to extrude that, and I'm also going to extrude that. And so we've now got a number of things. I'm going to go Z, plug in there, and then I'm going to just put in a random 10, and I'm extruding that down. So sometimes you just generalize, oops, I want to do it down, so I have to get a negative in there. So sometimes you're just trying to find the the easiest way of doing something. So I've got a mass that's too large. It doesn't need to be that large. And now I have this extrusion, and that's basically a sort of combination. And if I do a B-rep join, then I've got one solid out of all of that. So let's move all that down. Again, I don't need to, I can even internalize all of that data now that I've set it up, because I don't really need it again. It's just there for a constructive thing. So now we've got those two, we've got this solid. And so what we can do now is we can trim the solid, and we can go through and we can get this surface here. And then we can get that B-rep there, and we can trim it. Now, if I look now at what we've got, you'll see that that is now cut out. And so this here, let's call it something. Let's call it platform plus fill cutter. And that means that's the thing that we're using to cut with. And then now I've got that trimmed. And so what I want to do now is I basically want to join some things together. So I get a union, solid union, and I say I want to get this cut surface, no, sorry, this surface here. And then holding the shift key, I want to then get the platform surface. And then what I want to do is I want to then also get the fill surface. Why didn't it like that? Let me check. So in actual fact of that, so let's start the other way. Let's get a merge going here. Sometimes what you can do is an easier way to do it is to merge parts and say, okay, I want to merge that. Definitely. I then also want to merge this one because I've clicked the other part out, right? So I also want to merge that one. And then I've got now that item. I also want to merge that item. And so now I've got those parts together. I can see if it likes that more. Let's have a look. Something it doesn't quite like there. Let's see if we flatten it, it makes any difference. You know what? It doesn't hugely matter right now. It doesn't want to join them together. What happens if I do join B-rep? See what happens then. Yeah, likes that better. And so all I'm doing now is, it's hard to label these steps, and but we can. So let's now call this stage is really the trimmed surface from fill outline. And then what happens is that really this is the total surface, final surface. So I mean, there's lots of chopping and changing, and I actually did have to do a bit of work to get to this point. So I want to just acknowledge that, because you play around with, is it difference, is it this and that, until you find the right way. So I did start sort of recording this first off, and then I realized, I'm going to have to really play this to make sure I can do it correctly. So there is a bit of playing around to get that sequence together, because there's lots of things in the intersect menu that you can use in this part that I did use to get to this point. But as you can see, it's a kind of a cut and paste, it's sort of like a slice and dice is what I've been calling it process, But that's all the process of getting that thing. And so I can go systematically here and turn off the preview of all of these items. And then what I can do is I can just make my way through until I've got my final result. Really, this is Grasshopper 101, but at the same time, I love it. I call it it's like video games for grown-ups, but that's insulting to the grown-ups that already play video games. But for me, it's like that. So I feel a bit that way about GarageBand too. But anyway, so here we go. That's our surface there. And what we can do now is, if we want to get contours out of it, there's some things that are doing to get the contours, which is our next step. And so there is a contour command. So let's have a look at contour. And if we go create a set of brep or mesh contours, we get that. We start with our surface, which is the first one. We then, I'll turn this off, by the way. We then have, it says start point. Now, logically speaking, that start point is the lowest. And to strictly work from William's things, we want to start with his contours. And so let's then choose basically the bottom contour, because that's the lowest point in the thing. So we get a curve. We then set one curve, and we find that lowest one there, which is the bottom contour. And then we need to find a point from that. There's a lot of ways you could do that. You could choose a centroid. Probably the easiest way is to just extract its endpoints. So you see there's now those two endpoints there. So I'm just going to use one of those. And so I'm going to label this and just call this lowest contour. And then what I'm doing is I'm basically just plugging one of those endpoints. Doesn't matter because it's just getting a Z coordinate. Lowest contour there. And then what I'm doing is I'm then it wants to know the direction. Now that's obviously which way it slices. So the direction is going to be Z because of the fact that I'm basically trying to contour in parallel to the XY plane upwards. So that's there. And then it wants to know what the interval is. And William's original interview was 1. So I'm then going to say 1. And so then what I have is I have contours there. And so that's then giving me these contours, hopefully. Ooh, that's not a fun contour I just got there. What is that going on down there? I got something down there which is not properly worked out there. And so I have to work on that a bit further to find out what that glitch is, but it's obviously that there's a piece of geometry that's not really worked. What happens if I get this here and I unflatten that, what happens then? Still there. What are you, you evil contour thing down there? So I've got something there. What happens if I flatten that? That's making no difference. So it's obviously a glitchy piece of geometry there. So nonetheless, you get the principle and accept the aberration. And, I learn myself. And so you can also learn